Well, good morning again. I'm Reid Dixon. I'm a principal at Elenberg Fraser and the project architect for Premier Tower. And I suppose I've got the pleasure in sharing our design platform for the project this morning. So over the last 20 years, we've seen a shift really in Melbourne's CBD with the development of Docklands and South Bank, and more recently Fisherman's Bend. There's a real geographic shift west in the central city. And that's really been, I suppose, supported with the development of Spencer Street Station as the key transport node for the city. Our site sits on the opposite corner, on the corner of Burke Street and Spencer Street, really marking that entry into the city coming out of the station. Our city's been defined by, a sort of response to planning rules. And that's seen a collection of rigid building forms be generated as the sort of output of that. This approach, results in harshly geometric building masses, which interestingly have the greatest effect on pedestrian and urban and public realm environments, particularly through wind pressure. Our building sits proudly in contrast to this. It's a sort of jump off point for us, which is a change in approach for big buildings to become truly performative. We work closely with a collection of great engineering teams, namely the wind engineers out of Mel Consulting and our structural engineering partners out of WSP, to define a different architectural proposition for this project. One that's focused on approach rather than output, and how we could create an approach to this building that frees up the architecture to become a product of the process, focused on amenity for the city and for its residents, rather than typically just looking to limit its impact or effects. So for us, the building becomes this dynamic expression of a structural cantilever. So what we know from big buildings is that as they get taller and slender, they start to get measured against a slenderness ratio. The taller they get, typically, that response is dealt with mass concrete to try and provide a stable solution. Pairing here with our project at Premier Tower on Spencer Street, on the edge of the CBD, we're exposed to the harsh winds coming directly out of the southwesterly, sitting sort of on the edge of the whole grid in the built environment. Interestingly, going through this process as a sort of first principle approach to structural engineering, we identified that really what the building was calling for was not to become slenderer, but to actually add weight 2/3 of the way up the building. And this bulb basically was creating stiffness for us to resist the turning moment being impacted by the wind generation. What we found as we started to introduce the bulbs both at the bottom and the top of the building and change our undulation is that we ended up with a structural system that was able to perform both in tension and compression. And what we know from big buildings typically is that they're centered in gravity loads and basically build up the column size to try and deal with any resistance or oscillation in an alternate direction. What that meant for us is an undulating building volume that deals with providing a framework for effectively a webbed structure. So instead of big footprint columns, we went to skinny columns, allowing maximum amenity to the residential offers, also providing the most efficient solution structurally, and then started to undulate the form as we come down the building, which is an approach we're using to turn away the downdraft of the wind so that it never arrives into the pedestrian or public realm on the ground floor. You can start to see this approach when we look at the typical structural plan of the building. For an 85-story building, there's no large columns, there's no mega columns that hold the vertical resistance for the building. We've got a collection of stepping thin plates that move their way in and out of the building through a collection of different cantilevers, walking the edge of the building in and out at different aspects in the order of 7 meters in both directions. And what that undulation does is allows the moving moment for the column to have the greatest breadth across the building and basically give us the largest turning point for the structure. The typical approach of filling the center, we tested that they had huge impacts on the building footprint, where the web structure allows us to move away from that into sort of amorphous building form. The other benefit of that is it obviously gives us a collection of different residential offers that make their way up and down the building. So different range of apartment sizes, arrangements, all focused on amenity for residents with access to daylight and views. The result of the whole process for us was considering the architecture as an artifact. So what is left of this volume or building mass once we've applied all these pressures and interventions to it? You can see what we're left with is this sort of amorphous building volume that, as it responds to context immediately as an engineering piece, has the same effect with the building surface. So as the environment changes, this is a sequence of photos taken across 4 minutes, where as the sky moves across, we get this amorphous quality in the building surface, reflecting the different environment we're sitting in. Let's talk through some of these. Here we can see the arrival coming out of the Spencer Street station, footbridge building sitting in the corner. And then here you can start to see the stepping in and out of the volume from its minor condition out sort of 7 meters and back within the building. You can see that this is what starts to turn the wind away as it comes down the building. A little bit more, I suppose, on sustainability or performative design. I think it gets talked about too much as additional technologies into the building. Here we've embedded the engineering within the building itself. So the building uses a series of technologies. I've already spoken a little bit about the environmental wind reduction. We're also using a heat transfer system that allows us to use the benefit of the heating on the northern side of the building to transfer heat to the southern side, and in reverse when we've got a cooling environment, using the cooling climate of the southern elevation to cool the northern side. The environmental wind design and structural proposals saw a huge reduction in concrete in the project, but obviously has huge embodied energy benefits for the project. And finally, I suppose the glass procurement, which for us sees the envelope of the building as a high performing double glazed unit with a low E coating and dual direction layout that gives the building its different qualities, reflecting the different metal flakes in the glass. One final point just quickly is, I suppose, that we see the future of multi-residential building being mixed use. Probably haven't seen that be as prominent as the last 2 years, where in this building we're providing 4,000 square meters of layered communal area for residents that deal with everything from integrated service and retail office on the ground floor to active wellbeing floors on the top of the podium, through to entertainment and business uses to climb further up the building. Just flip through some of these images quickly.